Friends, welcome to part 1 presentation on chapter 5 that deals with enterprise systems. Just to put things a little bit into the context, I would like to bring your attention to the fact that with this chapter we are entering part 2 of our textbook and also of our course. Now, as you remember, in the first part we talked about, first of all, strategic importance of information technology and information systems. That was chapter 1, I believe. Then we talked about the most fundamental building blocks of information systems. We talked about hardware, software, networking, and also data. So starting this chapter, we will be more on the organizational enterprise side. Just like we talked about managerial issues and implications with respect to hardware, software, networking, and data components, now we'll be talking about managerial or organizational implications of enterprise systems. The entire part 2 is broken down into the following 2 subparts. First of all, the first subpart deals with intra-organizational systems. Now, as you know, intra means inside, meaning within one single organization. So as a part of that subtopic, we will talk about enterprise systems, which is chapter 5. We will also talk about managerial support systems, which is a more specialized form of enterprise systems. And then when we cover chapter 7, we will talk about inter-organizational systems. Now, inter is different from intra, and as you may know, intra means among or across organizations. So those are like broad cross-organizational information systems, and typically those systems are implemented over the internet. So this is an overview of part 2 of our textbook and also of our course. So now we're gonna get more into the subject matter of enterprise systems. That's what chapter 5 is all about. And then, as I said, we'll talk about managerial support systems, which is a more kind of specialized form of enterprise systems. But before we go into the main subject matter of chapter 5, which is enterprise systems, we'll talk about some fundamental concepts in computing and IT management that are very much relevant for enterprise systems. Now, first we will talk about batch processing. Now, batch processing means that a group or a batch of transactions are accumulated and processed all at once or all at one time. So schematically, it can be something like this. You have a operational level employee, let's say a clerk, let's say account receivables clerk or sales clerk, who is recording transactions manually using paper. Okay. Now, once those manual records are processed, they're compiled into one collection and then just keyed in or entered in a particular information system. So once all this information from paper transactions is entered, all those transactions are processed in batch, meaning as one single group. Okay, so there's no like real-time processing of those real-time data entry and real-time parsing of those manual paper-based transactions. So it's all processed in one batch. And then it's the way it's processed is that it's being parsed into a computer database. And then then once it's processed by the computer, it's added to a master file, some kind of centralized organizational record. And also some periodical reports can be generated from that. If you remember our case about Natural Springs, that's the kind of system they were trying to implement in their organization, where accounts receivables and accounting clerks at the factory would enter transactions using their own internal information system that was compliant with Russian standards. So they were not really doing paper transactions, but still they were doing it kind of in a manual way with respect to the information system that was implemented by the CFO in the St. Petersburg office. So they were keying in all those transactions, and then once a day, they would use dial-up connection to call from the factory to the central office in St. Petersburg and reconcile their master file with all those records that were done at the factory location. So that's the idea between batch processing. It means you accumulate transactions and then you process them as one single batch. Now, the key disadvantage of this kind of approach is fairly obvious. There's a time delay before the master file is updated. So in other words, there's always that lag between a particular transaction happening and the time when this transaction is actually reflected in the organizational master file. Now, a second or alternative approach to processing is the so-called online processing approach, which means that each transaction is entered directly into a computer when it occurs. So in other words, transactions are recorded and entered into an information system in real time. Now, there are some nuances here. There are some distinctions between interactive systems, meaning it's like a fully online, fully real-time system, which means user interacts directly with the computer. So whenever there is a transaction, user records the transaction, and that transaction is entered directly into the central computer system. And then you have inline system. It's somewhere like in between fully interactive system and batch processing system, where it provides for online data entry. In other words, data entry is done in real time. However, processing of transactions is deferred for batch processing, meaning data is entered in real time at the clerk location. However, there's still, those transactions are still accumulated into one batch in order to update a master file. So this is like a hybrid in-between approach. Now, even up to now, you see like some examples of this kind of inline approach. Like sometimes you call, let's say, your cell phone operator or your bank, and sometimes they would tell you something like this: well, thank you for updating your information. You should be able to see the changes tomorrow or in a few hours. So that's kind of suggests that they have an inline system, meaning whatever you do with them over the phone is entered in real time. However, it takes time for the central system to be updated with whatever the person entered on your behalf. Now, this is like a brief comparison between batch processing and online processing. So, the essence of batch processing is that there's significant delay before master file is updated, while online processing updates master file in real time. It takes a fraction of a second to update the master file. Now, because of this, batch processing is less expensive, while online processing is more expensive, because you need to have a very powerful bandwidth, networking bandwidth, and very powerful IT infrastructure in general. We're talking about hardware processing capacity. We're also talking about software throughput. So because if you have millions of transactions happening per hour, then the kind of load, the kind of capacity that's required to handle all those millions of transactions per hour is really demanding. So that's why you need to have a very expensive IT infrastructure in place to handle online processing. Now, another thing worth noting is that some applications, they're naturally suited for batch processing. In other words, there's no need to have online real-time processing. And one example of that would be payroll, right? Because payroll is typically processed once a month or bi-weekly, depending on the kind of, depending on the country and depending on the kind of labor law or just simple managerial practices. So basically, like your working hours are accumulated for 2 weeks or for 4 weeks, meaning the duration of 1 month, and then at the end, your monthly payment is calculated. So payrolls are processed once a month typically, so there is no need for any kind of online processing. But some applications, they need to be processed in real time. An example that comes to my mind is, let's say, stock trading, because when you process stock transactions, let's say buying and selling stock, a lot of things can change within a few hours or even minutes. The price can change. Somebody can find another client for the transaction and stuff like that. So those kind of applications typically require online processing. Or maybe credit card transactions, they require online processing, because if you have a particular credit limit or if you have a particular balance on your debit card, and let's say there is a 3-day lag or 2-day lag between your transaction, your purchase, and when this purchase is reflected in your account, then you can use this lag to kind of buy things that go way beyond your credit limit, right? So that's why online processing is important for credit card transactions. But overall, giving those trade-offs, most companies, they go for hybrid system, that combine both online data entry and batch processing. I would say that this is true, but as IT infrastructure is becoming more powerful and less expensive, a lot of organizations and a lot of applications are moving closer to the online processing mode. Now, another concept worth reflecting upon when we discuss enterprise systems is that some information systems, they are tied to a specific organizational function. Now, as you know, any kind of business, any kind of commercial organization typically can be subdivided into several functions, and those typical functions include, among other functions, marketing, accounting, HR, engineering, can be what else? R&D, research and development, finance. All kinds of functions, can be included under the, or departments can be included under the umbrella of one single organization. It depends on the industry type and the type of organization. So some organizations, they're designed specifically for individual functions. All right. For example, there can be some kind of accounting information system for processing accounting transactions. So in that case, those would be functional information systems. Now, enterprise information systems, by definition, they are largely cross-functional. They encompass more than one function, and sometimes they encompass, they automate work of all functions within an organization. So most enterprise systems are cross-functional. Now, there's another idea of classifying information system according to the level of the organization where those systems are used. For example, some systems, they are for capturing transactions at the operational level. Then you have like one level higher where certain reports or let's say invoices are generated for supervisors or middle management. Then you have information systems that generate reports that aggregate all this transactional data for middle management. And then you have the so-called executive information systems that provide highly aggregated information for top executives, and that information is typically based on this operational data. So what this diagram illustrates is that some systems can be classified in accordance to the level of the organization which they serve. They'll have different interfaces, they will use different data inputs, and so forth. Okay, but once again, if we relate this to modern enterprise systems, it looks like most modern enterprise systems, they automate work at all four levels. In other words, anything that is done within an organization, regardless of which function is involved, and regardless of which level of the organization is involved, so all those levels are automated with one single enterprise system. Now, one of the first research projects that I did when I was a doctoral student was actually a research project on an enterprise system called PeopleSoft implemented at the University of Houston. And they started small. They started by implementing certain finance, I think they started with the finance module, then they went to HR module and so forth. But eventually the kind of integration that they achieved, across functions and across levels was simply amazing and sometimes scary, because whatever you do as a student or as an employee at the operation level is immediately reflected in your account, and then all those things are immediately aggregated for top management. So they will say, "Oh, how come you're doing this or not doing this?" And then all that information that is sent to middle management is aggregated for top management report. So they achieved cross-functional and cross-level integration and automation by implementing PeopleSoft across their campuses. Now, another computing concept that seems to be relevant for enterprise system is distributed computing or distributed systems and client-server systems. Now, distributed system means that the processing power or the overall processing capacity is distributed across several locations. For example, there can be thousands of computers within an enterprise, and each of those computers is involved in processing organizational data like as an equal node. Okay. Now, one specific term for this kind of paradigm or architecture is grid computing, where instead of having one powerful centralized computer, you have hundreds of commodity computers connected together that act as one single supercomputer. So those are distributed systems. And then you have client-server systems, where you have a client and a server. Server means a powerful computer. It's reflected right here. It's a powerful big machine responsible for most of the transactions. However, some transactions are also done by client computers. Typically client computers are smaller, less powerful desktop computers utilized by specific employees. And then there's a middleware that connects client computers to servers, so that some of the load, some of the processing, some of the data storage, and some of the software installation is done not on the server side but on the client side. So it helps to alleviate the burden that is being put on server. I would say that when it comes to enterprise system, this kind of architecture client-server paradigm has been quite dominant since 1980s or 1990s. I would say nowadays with this big data movement, there's a greater shift to distributed systems where there's no centralized server, but instead you're using commodity servers, commodity desktop computers that are all connected together in one grid that acts as a single processing unit. And there are a lot of software applications nowadays that allow companies to implement, distributed systems. One example that comes to my mind is Hadoop server that is created specifically for handling large data storage requirements. So Hadoop allows you to use commodity hardware to distribute storage of data and processing of data across different computers without the need to have a centralized, data storage and data processing that is carried out with the help of very expensive supercomputer. So I would say client-server systems are still dominant when it comes to enterprise systems. However, a lot of organizations are moving closer to distributed systems. Now, another important trend that seems to be behind a lot of enterprise systems nowadays is the so-called virtualization concept. Now, there are two subtypes of virtualization. First of all, you have server virtualization. Now, server virtualization means this: physical server, meaning like a box, the actual physical hardware, is being split into multiple virtual servers, meaning those servers, they belong to this one single box. However, they are treated as different servers. So because of that, each virtual server, each partition of that server can run its own full-fledged operating system. And then physical servers, they act as hypervisor program creating virtual servers. So they manage like all the servers on one machine. And because of that, each virtual server can be employed as a standalone physical server, reducing the number of physical servers needed. So this is more like of an economic trend where, thanks to the software, you can utilize, one powerful server can be utilized by several organizations. One example of that comes to my mind, which has been a very bold, a very successful business move, is GoDaddy.com. I think those were the guys that were very big. And if you don't know what GoDaddy is, it's a very well-known web hosting services company. In fact, it's considered to be like the McDonald's of web hosting, because they offer like simple, cheap, inexpensive web hosting solutions to individuals and small business owners. And server virtualization has been a dominant technology behind their model, because they were saying, look guys, well, in the old days, if you wanted to run a website, you had to basically purchase and install your own web server. So what GoDaddy and then many other web hosting companies did, they kind of said, look, if you only need to have a small website, there's no need to purchase your own physical server, meaning like a box, computing box. What you can do, you can share, one of our servers, and that server can be split among, 100 different websites, and and although you're sharing that server, you will be able to see, the server as if it was like a dedicated server, installed and maintained specifically for your website. So they offer that, and of course, instead of buying, hundreds of servers to serve hundreds of clients, now they have one server serving hundreds of clients, right? So that allowed them to offer like those cheap, not very powerful, but yet inexpensive web hosting solutions to individuals and businesses. And then there's something called desktop virtualization. It means that it's implemented through a client-server computing model, but it means that you don't have much installed or stored on your own desktop computer. All the software that you're accessing is actually you're running that software and data from the server. Okay. However, like from the perspective of a user, it looks and feels like as if all those applications were run from his or her individual computer. Now, this trend or this concept about in relation to desktop virtualization is also largely related to IT management, because it makes it much easier to organize, installation and update of software for individuals. For example, if everybody is using, is running an SPSS, which is a statistical package, an SPSS application from the server, and then you as an IT manager, you want to update everybody to a new version of SPSS, there's no need for you to go to each individual user and ask him to install this new updated version. There's no need for you to send any kind of update patches. What you will do, you will just update the central server, and then each individual will access it. Also, this desktop virtualization, I think at least for some point of time, it was like a loophole for some organizations when it comes to overcoming licensing requirements, because some software vendors, at least in the past, they would specify that if you buy one license, it can be only installed on 1 or 2 computers, something like that. But what they would do, they would put this IT managers, they would put this application on a server, and technically speaking, it is installed on one server. However, many individuals will be accessing it. So that's where this idea of concurrency came in, because of virtualization. So nowadays, software vendors, they say you can only have 10 concurrent users, which means that they're saying, well, okay, we understand that you may install our application on a server, and different users may be using it, although it's installed on one single machine. So that's why we have this concurrency clause, meaning no more than 5 or 10 users at the same time can access this application. But again, it's largely related to IT management. This technology is largely related to the goal of IT managers to maximize the efficiency of their IT infrastructure. Another important building block of today's enterprise systems is the so-called service-oriented architecture. What it means is that each software application is not treated as some kind of standalone application, but it's treated as a service, meaning that anybody can access it meaning any kind of other software can access the functionality or the services provided by these applications through a certain protocol. Okay. So this allows to reuse software as building blocks. Like you have all those services, and all those services can be assembled together into one bigger, enterprise application. And of course, nowadays, all those, service-oriented architectures are largely or often implemented over the web, over the internet. And there are a number of technologies that are used to implement software as a service. For example, XML. I think nowadays JSON, which is like a different implementations or web-based implementation of the same kind of idea, where it's like a data, open data exchange protocol for web applications. Then, some other technologies that are used in relation to web services are as follows. You can see it right here. So software as a service concept or web services, this is another paradigm, another approach, or another set of technologies that seem to be driving enterprise systems nowadays. Okay, friends, so this concludes part 1 of our video presentation on Chapter 5. Thank you for listening.